This is the third day of section 2.4. We just have a little cleanup to do here at the end. We had already completed A, and this was part of those extra examples that we had. And what we had was that they gave us one of the zeros, and then, as it says for this whole group here, we use synthetic division to get things simplified, and then if necessary, we can use completing the square or the quadratic formula to finish those up. And we had the first one, which wasn't too bad, and then we get this one. And it says f of x equals x to the fourth plus 3x cubed minus 16x squared minus 27x plus 63 if f of negative 3 is 0 and f of 3 is 0. Well, that's a huge hint right there. I mean, they're giving us two of them, two of these zeros. So what we want to do is use synthetic to whittle this down to a quadratic and see what we have. We have 1x to the fourth, 3x to the third, negative 16x squared, negative 27x, and 63. And none of those terms are missing, so we don't have to put any zeros for spacers. And then you start with the 1, and again, outside the box you multiply, and then you go inside the box and you add. Outside the box you multiply by negative 3, inside the box you add. Outside the box, multiply, so negative 3 times negative 16 is 48. Inside the box we add, so basically we're going to be subtracting 8 minus 7 is 1 and 4 minus 2 is 2. And then negative 3 times 21 does give us negative 63. So we verified that negative 3 works. Now we're not going to start over. We're going to continue to work this down. Like I said, we're going to whittle this down to a quadratic. So now we bring down the 1, and this time outside the box we multiply by 3, put it inside the box, add inside the box. Multiply 3 times 3 and get 9, add inside the box. Multiply negative 7 times 3 and add inside the box. So we verified the two zeros that they already gave us. And what we need to see is what do we have left? And we always start with remainder constant x, x squared. And if there were more numbers here, we'd do x to the third, x to the fourth, etc. So we have x squared plus 3x minus 7 equals 0. And I take a look at it and I think, well, there's no greatest common monomial factor. It is not a perfect square trinomial. But I'll just go ahead and use completing the square because that'll solve any quadratic. And it's not factorable. We don't have two numbers that multiply to negative 7 and add to 3, at least not integers anyway. So we would go ahead and move the 7 over. And then we would use our little b over 2 squared. So b in this case is 3. And 3 halves squared would be 9 fourths. So we're going to need to add 9 fourths to both sides of this fraction. And then we have to remember that 7 is the same thing as 28 fourths. So we're really going to do 28 fourths plus 9 fourths over there. But over here, all we have to do is think about the math that we just did. And what we did to get the 9 fourths was square 3 halves, b over 2 and squared. So now on the right-hand side, we have 37 fourths, and we have x plus 3 halves, the quantity squared. Well, to undo squaring something, we have to take the square root. And whenever we do that, we have to introduce that plus or minus. And the square root of 37 is not nice. 37 is prime, so we're just going to leave that the square root of 37. But the square root of 4 is 2. And then we go ahead and subtract 3 halves from both sides. So we'll have negative 3 halves plus or minus the square root of 37 over 2. And I remember they started us off with these two for zeros. And we now have two more. We have negative 3 halves plus the square root of 37 over 2, 0, and negative 3 halves minus the square root of 37 over 2, 0. And we have 4 of them. And if we go back and look at the original, we will see that this was a 4th degree polynomial, which should have 4 zeros. Now, something like this, you just might want to take a look and see, well, what would the calculator give me with this? And if we graph that polynomial, here's what we see. And we can definitely see that negative 3 and 3 that they were talking about. So second table, it's taking it a little bit here to do what I'm asking it to do. Second table, there we go. And we see the 3, 0, and there's a negative 3, 0. And then we'd use our second trace feature to find the zeros. And right now it's at 0.63, so I'm just going to bring it back. It's got our x's way up there at 46, 39, etc. So now I can start to see it. This is the 0 that I had at -3, which I don't need because I already know that one works. But just kind of interested in what we see for this one. So above it, enter. Below it, enter. Enter through guess. We would not have recognized that as a fraction that we know, -4.541381. And again, this is the calculator apologizing because it didn't get a perfect 0, but it got pretty doggone close with 1 times 10 to the -11th. And the other 0 that we have over here is another unrecognizable 0 because of the radicals that we had involved in this one. But, you know, we talked about how if all else fails, you grab the graphing calculator and you see what you can get. Now let me deactivate this one. And for the next problem, we are going to want that one activated. All right. There we go. It's being a little ornery. There. So the next problem, part C. F of x equals 10 plus 5x minus x cubed minus 7x squared plus x to the 4th. So what I notice about this is it is a degree 4 polynomial. And I see that it obviously is not in the right order. And because we're going to end up using synthetic, we really want to put that in order. And while you're doing it, you can think, okay, I've got 4, 3, 2, 1, 0. They are all there, you know, while you're reordering this in standard form. But I see that they're telling me the square root of 5 is 0. Now, this is a big step. We need to know, without them telling us, that if the square root of 5 is working, negative square root of 5 is going to work also. So what we're going to have to do is a little synthetic with radicals. And let's see what we can do. 1x to the 4th minus 1x to the 3rd minus 7x squared, 5x, and 10. Everything is represented. Bring the 1 down. 1 times the square root of 5 is the square root of 5. Unfortunately, you can't add -1 in the square root of 5. One's an integer and one's a radical. So it's going to be -1 plus the square root of 5. And this is where it's kind of helpful to have a little piece of scratch room on your paper. Because the next thing we have to do is multiply. So the square root of 5 times the quantity -1 plus the square root of 5 will be the negative square root of 5 plus square root of 5 times the square root of 5 is the square root of 25, which is 5. So what we need to put in this next space is 5 minus the square root of 5. But we have -7 plus 5, which is -2 minus the square root of 5. And now we're back to needing that little piece of scratch paper off to the side here to multiply that by the square root of 5. And that will give us -2 square roots of 5 minus the square root of 25, which is 5, which would be -5 minus the square root, minus 2 square roots of 5. And I should have spread this out a little bit farther. I'm going to really be sinking here for room. All right, but 5 and -5 are going to cancel out, and we will get -2 square roots of 5. And we go one more time out by the square root of 5 times -2 square roots of 5, and we will get -2 square roots of 25, which is going to be -2 times 5, which is -10. And we do get that 0. Now, that math there doesn't necessarily make everybody happy because they're like, seriously? Now I've got to do that with the negative square root of 5. But once you get one of these out of the way, the math is usually easier the second time through. So I wouldn't get too worried about it. Bring the 1 down, multiply by negative square root of 5, and you notice, hey, the square roots of 5 are going to drop out. So -1 times negative square root of 5 is a positive square root of 5. Well, now those square roots of 5 will drop out, and I'll get -2. -2 times negative square root of 5 is 2 square roots of 5, and that gets me a 0, which is great. I mean, I just verified that I have my f of square root of 5 equaling 0 and my f of negative square root of 5 equaling 0. And now I need to see what I have left. And what I have left is remainder constant x squared. And what I'm trying to see here is, can I get it by algebra? You know, do I maybe not have to bother putting this in the calculator? Because obviously the square root of 5 is not something we're used to working with, so we probably wouldn't recognize it anyway. And I'm looking to see, because this doesn't have a greatest common monomial factor and it's not a perfect square trinomial, if I can find two numbers that multiply to -2 and add to -1, and that's -2 and +1. So that means my last zeros are going to be at 2 and -1. So my zeros for this problem were square root of 5, 0, negative square root of 5, 0, 2, 0, and -1, 0. So we did synthetic with radicals, but it really wasn't that bad. You know, it's not that awful. The key to this one was knowing if they give you the square root of 5, you have to use the negative square root of 5 also. That irrational zeros come in pairs, and so do imaginary. Now, this little bugger, whew, look at that. X to the 4th minus 5x squared, yep, they're not in order. So let's get them in order. And again, thinking, is anything missing? 4, 3, 2, 1, 0. They are all there. But then we see this is going to be a little tougher. And that's because we have f of 1 minus the square root of 2 as one of our zeros. Well, that means 1 plus the square root of 2 will also give us a 0. And it's just a matter of, you know, which one do you want to do first. So we have 1 minus the square root of 2 as one of the zeros. X to the 4th, x to the 3rd, x squared, x, and the constant. Again, even if the constant's missing, you have to put a 0 in as a placeholder. You bring the 1 down, and you say, well, 1 times 1 minus the square root of 2 is 1 minus the square root of 2. And then we have -2 plus 1, so that'll be -1 minus the square root of 2, because we're only really combining like terms here. And then you have a little bit of scratch room over here where you say, okay, here's what I need. I need 1 minus the square root of 2 times -1 minus the square root of 2. If I do some FOIL on that, that'll give me -1 in the front. Outside would be negative square root of 2. Inside would be positive square root of 2, and that'll be gone. And then last times last, a negative and a negative give you a positive. Square root of 2 times the square root of 2 is square root of 4, which is 2. And that will give us 1. Well, that worked out kind of nice. So -5 plus 1 would be -4. And then we have to distribute that -4. So we'll distribute that through 1 minus the square root of 2, and that'll be -4 plus 4 square roots of 2. Needing the scratch paper room again, because we need to take, oops, hang on 1 second. I'm thinking about the next step in my head. 8 minus 4 is 4. 4 plus 4 square roots of 2. And we have to multiply that by 1 minus the square root of 2. There we go. Let's do a little FOIL here. So first times first is going to be 4. 1 times 4 is 4. Outside times outside will be plus 4 square roots of 2. But good news, inside times inside is minus 4 square roots of 2, so that'll be gone. Last times last, we'll have negative square root of 2 times 4 square roots of 2, which will be -4 square roots of 4, and square root of 4 is 2. So we really end up with 4 minus 8, which is -4, which should not shock us at all. So there's our 1 minus the square root of 2. And like I said, that's the tough one. So next thing to do would be 1 plus the square root of 2, knowing this is going to work out a little bit nicer. Bring down the 1, multiply times 1, and notice that not only are the 1's gone, but the square roots of 2 are gone this time as well. Multiplying, we get 0, or -4 there, and then you're just distributing that, and that will be -4 minus 4 square roots of 2, which gives you a 0. And again, at this point, we would hope, hey, can we find the other two by algebra? You know, maybe we don't have to grab a calculator. So remainder constant x squared. We have x squared minus 4 equals 0. And you could either factor that as a difference of 2 squares or just go right to solving it. But it's pretty obvious that our two remaining zeros will be -2 and 2. And so we had 4 zeros with this because this was a quartic. It had x to the fourth. And then we just have to write them all out. And yeah, I kind of write so big. I'm going to move this down a little bit. And we can get those zeros. They gave us one, and we, well, by knowing that they always have irrationals in pairs, we found the remaining 3. So we have 1 minus the square root of 2, 0. 1 plus the square root of 2, 0. And then the nice 2 zeros that we could find algebraically. Now at this point, remember, you could also say, hey, that's x squared minus 4. Go to your calculator. It would be kind of silly, but you could put that in your calculator and see what you get. But those are our 4 zeros. This one, like it says, calculator permitted. If p of x equals 8x to the 5th minus 14x to the 4th minus 22x to the 3rd plus 57x squared minus 35x plus 6, list all your possible rational zeros. Pardon me. Then find the simplified exact real zeros. Use the calculator to help you find rational roots. And use the quadratic formula if necessary. Use completing the square if necessary. That's what we want to do. We want to get really, really good at that process of completing the square. So, list them all. Well, 6 is in the back. That's our constant. So what we're going to have to do is write down all the factors of 6, all the numbers that divide nicely into 6. Then we have an 8 in the front. So plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Now, they did say we have to list them all. So we go through, and I'm going to take this 1 and divide it by everything below it. 1 divided by 1 would be 1. 1 divided by 2 would be plus or minus 1/2. 1 divided by 4 would be plus or minus 1/4. 1 divided by 8 would be plus or minus 1/8. Done with that one. Go to the next one on the list, which is 2. Plus or minus 2 divided by plus or minus 1 is going to be plus or minus 2. Probably should just put a comma in here instead of another equals. And then we have 2 divided by 2, which is 1, and that's already on my list. 2 divided by 4, which is 1/2, and that's already on my list. And 2 divided by 8, which is 1/4, which is already on my list. That one's done. Then we go to the 3. So we'll have plus or minus 3 over 1, which is plus or minus 3. Plus or minus 3/2, plus or minus 3/4, and then plus or minus 3/8. And now we're done with the 3. Go back with the 6. Plus or minus 6. Plus or minus 6 over 2 would be 3, and that's already on our list. Plus or minus 6 over 4 would reduce to 3/2. That's on our list. Plus or minus 6/4 would reduce to 3/4, and that's already on our list. So those are all of our possible rational zeros. Now what we have to do is narrow that down by using that graphic calculator to get a peek at this and see which ones we should try. Boy, was this ever a bear to punch in on this calculator. So what I think I'm going to do is just clear these out. All right. So there's our monster polynomial right there with the 8x to the 5th. And I'm going to activate that one by turning on the equals. And just going to try that Zoom 6 window. It's working. It's just taking some time here. So pretty solid with the -2. You know, it looks like -2 is going there, and I can always use the table and take a peek. And I've got -2 and 1, 0 as definites. And then we can go ahead and see if isn't one of these others that's something nice, you know. So second trace the 0. And we might as well go from left to right. We know the other one is -2, so I'm just going to hit enter and then get below it a little bit there. Enter, enter. That is not a normal fraction that we would know. So let's go to the next one and hope things work out a little bit better. Second trace, number 2. And I'm going to move Blinky here. And above. Hopefully that has, go back there. Now I can see I have a positive y. Enter, enter through guess. Well, that one we know, 75/100 is 3/4. So we have 3 of these. One of them is something nasty, which tells us it has a radical in it. Well, radicals always come in pairs. So we can use the -2, the 3/4, and we can use the 1, and we can whittle this down to something that will be a quadratic, and then we can solve it from there. So -2, 1, and 3/4 appeared to be the nice ones from the calculator. So I'll just start with -2. It doesn't matter which of these you start with, by the way. And I have 8x to the 5th, -14x to the 4th, minus 22x cubed, 57x squared, -35x, and 6. And they all are there. We bring down the 8. We multiply outside the box. We add inside the box. Multiply outside the box, so -2 times 30 is 60, and then add inside the box, but this is really like subtraction here. And then multiply outside the box. And again, it's kind of like subtraction inside here, so we're really taking 16 minus 7, which is 9, and then 6 minus 5 would give us 1, so that would be -19. And then we have -2 times -19, which is 38. We get a 3. -2 times 3 is -6, and beautiful. -2 works. Go after it with a 1. Bring down the 8. Multiply, add inside the box, multiply, and again it's kind of like subtraction with some of these, and multiply, and add, and we get a 0. So 3/4, it's not going to be that awful to do the synthetic with, especially when you look at the numbers that we're going to get here. You bring down the 8, and you say, okay, 3/4 of 8, that's going to be 6. And I have -22 plus 6, which is -16. And if you have to, you come out to the side and you go, okay, 3/4, -16 over a 1. Oh, look, that's a 1 and that's a 4, that's -12. So don't feel like you have to do that in your noggin if fractions bug you. 16 minus 12 is 4, then 3/4 times 4 is, of course, 3. And that gives us our 0. So now what we're up against is how are we going to get the last couple? So remainder constant x squared. And we have 8x squared minus 16x plus 4 equals 0. So the first thing I notice is, hey, 4 will come out of all of that. And maybe, just maybe, we've got ourselves something factorable here. So you look at it and you say, well, I already took out the greatest common factor. It's not a perfect square trinomial because there's a 2 in the front. And I'm going to flat out tell you, you try the 1 and the 2 and the 2 and the 1 in the front, and it has to be a -1 and a -1 in the back. It isn't going to work. So the 4 that's in front does not have an x with it. There is no answer coming from this 4. So what we have to do to get the remaining answers, the remaining zeros, the remaining solutions, is solve this. And because we're going to complete the square, we're going to go ahead and move that 1 off to the other side, but we have to divide by 2. And that's because completing the square only works if you have a 1 in front of your squared term. And then we'll have x squared minus 2x equals -1/2, which is not that scary at all. And then we'll take b divided by 2 and square it. And that's -1 squared, which is 1. So x minus 1, the quantity squared, equals 1/2. X minus 1, taking the square root of both sides, equals plus or minus. And now we've got to do something about the square root of 1/2. The square root of 1 over the square root of 2 will be 1 over the square root of 2, but we have to rationalize the denominator. So square root of 2 over the square root of 4 will give you the square root of 2 over 2. And finally, add the 1. So there are the last of the zeros, because this one was a quintic, and we should write them down. We have 1 plus the square root of 2 over 2, 0. 1 minus the square root of 2 over 2, 0. We had -2, 0. We had 3/4, 0. And we had 1, 0 as the 5 zeros for that wonderful quintic that we had there. There they are. Now we have one left to go, and this is a challenge problem, but it's a good one. It's not necessarily difficult. You just have to know how everything works. So find the given value of k so that the given divisor is a factor of p of x. And the first thing I think of when I see a factor is, hey, my remainder is going to be 0. My remainder has to come out to 0. So if d of x equals x plus 1, that means what I'm really doing is I'm looking at my 0 of negative 1. So that means if I put negative 1 into this, I'm supposed to get 0. Well, then that would mean this is 0. And everywhere I see an x is negative 1. Well, that doesn't look so bad. So negative 1 to the 4th is 1. That'll be 3. And, oops, forgot my little squared there. Negative 1 squared is 1, so that'll be plus k. Negative 2 times negative 1 is plus 2 plus 1. So 0 equals k plus 6. Subtract 6 from both sides. There's k. There it is. So what we have to understand is when you talk about something being a factor, its remainder is 0. So on the other side, I'm not going to use x minus 2. This is x minus h. I'm going to use 2. If you put that in, you're supposed to get 0. So 0 equals 2 times 2 cubed plus k times 2 squared plus, I'm going to write 2k, but I probably shouldn't be skipping steps here. K times 2 minus 5. So 0 equals 2 cubed is 8. 8 times 2 is 16. 2 squared is 4. 4k. K times 2, 2k minus 5. So we would have 16 minus 5 is 11 plus 6k. Subtract 11 from both sides and divide by 6. So these problems are not difficult mathematically. It's just that you have to pick up on the fact that one little word, factor, is so important because it means it's going to give us a 0. And now, we are done with all of our wonderful objectives from 2-4. We had used long division and the division algorithm, used the remainder and factor theorems, used the rational 0 theorem, find upper and lower limits, and the day 1 assignment was 1 through 26. And if you need to, go ahead and pause the video so that you can get this assignment written down and have her completed in time for Wednesday.